continue with this. I explained the types of switches concept. Up to now, I given what are the different types of switches we are using, and the general classification of switches, and what are the types of switches in power electronics. In the same chapter, we go for how to calculate switching power loss and energy loss. The theory concept is first. Later on, we'll solve some problems also. Yes. Let us consider to explain calculation of switching energy loss or switching power loss. The concept is under types of switches concept only. That is calculation of average switching energy loss, average switching energy loss and power loss. Average switching, calculation of average switching energy loss and power loss. Yes. For that, let us consider the switching characteristics for a particular switch. Here I taken one example. These characteristics I already given in the practical switch explanation. Let us consider the characteristics for a particular switch. The general switch characteristics I am giving. Let the current through the switch is ISW. This is during switch is on condition, current rising, and switch is conducting. If the switch is off condition, current is falling. Yes. Let the voltage across the switch is VSW. Voltage across the switch is VSW. Yes. Let the amplitude of this current is I. Yes. Let the voltage across the switch is VSW. Understood. Now, if the current is rising, what about voltage? Falling. Voltage is falling. Let this is V, because it is on condition. If the switch is conducting, then there exists some conduction losses, but I am concentrating not the conduction losses. I am concentrating switching losses. Now, voltage is falling, then current is falling, then voltage is rising. Yes. Let this is time axis. This also time. And this is the characteristics during which condition? T on condition. Yes. These are the characteristics under which condition? T off. First, I want to calculate what is switching energy loss during on condition. What is switching energy loss during off state? That is average on state switching energy loss average off state switching energy loss. Then I want to calculate average on state switching power loss, average off state switching power loss. Once you know the on and off losses, then finally calculate what is the total power loss and what is the total energy loss in one operation. Total switching power loss, total switching energy loss. Okay. Now, first I want to explain calculation of on state switching energy loss. On state, during on state. What do you mean by on state? During on state means turn on is nothing but current is rising, voltage is falling. Turn on, that is during turn on. That is during turn on. During turn on. During turn on. That is turn on is nothing but current rising. That is current rising, current through the switch. Current rising and voltage is falling. And voltage is falling. Turn on is nothing but current rising and voltage is falling. Current rising and voltage is falling. Now average switching energy loss. Average switching energy loss during turn on. During turn on. Average during turn on. Average switching energy loss during turn on. That is E on state energy loss. Okay. Then how to define integral 0 to T on V into I into dt. Okay. How to calculate average energy loss? Integration of power is nothing but energy. Okay. Now to find average energy loss, I want to calculate what is voltage equation and current equation during turn on. Okay. Now see for current I. For current I, how to write the equation for current I? Okay. This is I for current I. I am writing for current I. Let directly also you can write. It is just like it is passing through origin. You can write y equal to mx formula. From that you write expression for I also. That is one method. Let this is during T on. During T on. Okay. You write expression is like this. It is just like y equal to mx. On y axis what you taken? Current. Let ISW is, assume that I. Okay. I equal to now slope now m y by x. Y is capital I by x T on x axis what you taken T. This is one way to write because it started from horizon. Directly also you can write like that. But every time if any characteristics are given during solving of the problems, every time we don't expect the characteristics from origin itself. The characteristics may be started at any point, but every time we don't apply this formula. Then if the characteristics are given started from origin or at any point, then this is the method you follow to write the equation. Go for the line equation. Okay. Then this is started from 0, 0. This is started from 0, 0. Yes, sir. Now, what are the coordinates here? X coordinate is T on, Y is I. Okay. That is, it is started from 0, 0 and X coordinate is T on comma, Y is I. Let this is X1, this is Y1, this is X2, this is Y2. Then what is the line equation you tell me? Y minus Y1 equal to Y2 minus Y1 by X2 minus X1 into X minus X1. Understood? Then on Y axis, what you taken? Current. I minus. What is Y1? 0. What is Y2? I. What is Y1? 0. What is X2? T on. What is X1? 0. On X axis, what you taken? 0. Then what is the equation for I? The equation for I equal to, what is the equation for I? The equation for I equal to I by T on into T. Understood? Similarly, I want to write the equation for voltage. Okay. For voltage V. For voltage V. Yes. Sorry. For voltage V. Let this VSW equal to V, small v. Okay. Then same, you follow the line equation. What are the coordinates here? 0, comma V. What are the coordinate here? T on comma 0. The line is changing from 0, comma V to T on comma 0. This is during T on. Understood? Then same, Y minus Y1 equal to Y2 minus Y1 by X2 minus X1 into X minus X1. Understood? What is, this is X1, this is Y1, this is X2 and this is Y2. What is Y? On Y axis what you taken? Voltage. V minus. What is Y1? Capital V is equal to. What is Y2? 0. What is Y1? Capital V by X2 T on. What is X1? 0. On X axis what you taken? Time. What is X1? 0. Then what is V equal to? Yes. Then V equal to, take a V minus V by T on into T. Then what is V equal to? Capital V is common, 1 minus T by T on. This is expression for voltage V. Understood? Without doing this also, directly also you can write. One observation, how to write directly for this type of waveforms. Okay. For rising slope, this is falling slope. How to write the expression for rising slope? The expression for rising slope is, directly you can write like this. Amplitude by time. That is amplitude by time into T. For falling slope, how to write the expression? Amplitude into 1 minus T by T on. The time is, it is during T on, that's why you take T on. If it is during T off, how to take? that you take T off. Understood or not? Okay. Then this is expression for V and this is expression for I. Once you know the expression for V and I, then what is the average on state energy loss? That is, I want to calculate average switching energy loss during turn on. That is, now you write expression for E on. E on. Okay. Then integral 0 to T on. What is the expression for V? V into 1 minus T by T on into I into I by T on into T. This is dt. Then integrate and substitute the limits. Then what you get? On state energy loss, on state switching losses, energy loss, switching energy loss. Then what you get? 1 by 6 V I into T on. This average on state energy switching losses. Understood? But I want average on state average switching power loss. Then what is the average switching power loss? Average switching power loss. Average switching power loss. Average switching power loss during on state. During on state. Average switching power loss during on state. Then how to write average switching power loss during on state? P on equal to how to get, if once you know the energy, how to get the power? We know that energy equal to power into time. But I want power na. Power is nothing but a on state energy power loss by time. Then what is the average on state switching power loss? P on equal to, that is 1 by 6 Vi T on by T. Then what is the average on state switching power loss? 1 by 6 Vi F into T on. Very, very important equations. Okay. This is the calculation during on state. Understood? Now similarly, I want to do the calculations during off state, during turn off. Okay, this I want to do during turn off. Please understand? Okay, note down this. And this is average energy loss and average power loss during turn on process. How you can calculate? Okay. Now you want to do these calculations during turn off. You want to do these calculations during turn off. Okay. During turn off. During turn off. It's okay. Current during turn off means, this is during turn off now. Current is falling. Yes. Current falling. And voltage is rising. Yes. And voltage is rising. Average switching energy loss during turn off. Average switching energy loss during turn off. That is off state energy loss. This you take T off. Off state energy loss. It's okay. Then E off equal to 0 to T off Vi into dt. Understood? Now I want to write the expression for current I. Without doing this analysis also, how to write directly I told already. Okay? How to write directly. Okay. Now we are writing expression for current I na. This is falling slope or rising slope? Falling slope. Then for falling means how to write expression for I? I equal to amplitude into, what is amplitude? I into 1 minus T by, this is during T on or T off? During T off. I equal to I into 1 minus T by T off. Then no need of all this derivation. For voltage V, how to write the expression? You tell me. For voltage V, how to write the expression? You tell me. Yes, sir. It is rising slope, na? Rising slope. Rising slope. Then V equal to amplitude is V, capital V, by during which time? Off time. T off by V by T off into T. Understood? Now you calculate what is the average energy loss, off state energy loss and off state power loss. Now average off state power loss, average switching energy loss during turn off, energy loss, off state energy loss, E of equal to integral 0 to T off into, what is expression for V? You written V by T off into T. What is the expression for I? You written I into 1 minus T by T off into dt. Then integrate and substitute the limits. Then what you get? Off state energy loss. Then 1 by 6 Vi into T off. Yes. What is the off state power loss? Off state average power loss. How to get expression for power loss? Energy by time. Then 1 by 6 Vi F into 1 by T is written as F. This 1 by T is written as F. F into T off. Now, what is the total average energy loss and average power loss? Now, total total average switching energy loss, average switching energy loss, average switching energy loss. Okay, that is on state energy loss plus off state energy loss. Okay, then what is the average on state switching losses? Sorry, average on state switching energy losses. On state 1 by 6 Vi into T on plus T off. Okay. This you can get one equation. Similarly, what is the total average switching power loss? Total average switching power loss. Switching power loss. P average equal to on state switching power loss, off state switching power loss. Yes, on state and off state switching power loss. Yes, then P average equal to what you can get? 1 by 6 Vi F into T on plus T off. Extra you can get the frequency. This important equation, this important equation. Okay, like this we calculate the switching energy loss and switching power loss during on state and off state. Okay, this is off state switching losses, this off state power losses. Total average switching energy loss 1 by 6 Vi into T on plus T off. Total average switching power loss 1 by 6 Vi into F into T on plus T off. But one observation here, all these equations I written for linearly rising and linearly falling only. These equations are applicable for linearly rising and linearly falling. That means you written as a note, like this. For linearly rising, you written as a note like this. Okay. If the characteristics are like this, okay, the characteristics are like this. It may be voltage or current, whatever may be. If it is linearly rising, linearly falling, and linearly rising, let this is I and this is V. Let this time is T1. It may be on time or it may be off time, whatever may be. For this type of characteristics, what the total average energy loss? 1 by 6 Vi into T1. Directly write. No need to derivation all this. What the average power loss? In this case, 1 by 6 Vi F into T1. This formula you remember. Without any derivation, for this type of characteristics, these formulas are applicable. Current is rising. Here I taken current is rising, voltage is falling. Or it may be you take voltage is falling and current rising also. It may be linearly rising and linearly falling characteristics are given. Then what is the formula for average energy loss? 1 by 6 Vi into that type into T1. But power loss means extra frequency we can get. 1 by 6 Vi into F into T. Extra frequency term we can get. Okay. Okay, this is the calculation of average switching energy loss and average switching power loss. Okay, for a given characteristic. This only concept I explained. Based on this, how to solve the problems later on we'll see. Okay. Okay. Now this is the concept of calculating the average energy loss and power loss.